So this is what we call our GroundOwl sensor suite. It's made up of this electromagnetic induction sensor here. Occasionally we'll have a ground penetrating radar. We're working with some gamma ray sensors too. So we consider it to be a full suite, right? And a unimodal. But this is our electromagnetic induction sensor. In layman's terms, a big metal detector. It's going to, essentially read the EC readings from the ground electrical conductivity at 4 different frequencies, which helps us characterize variability throughout that field, regardless of the actual attribute that we're looking to map. So whether it's your NPK, whether it's compaction, whether it's pH, we can use this to characterize that variability. We'll typically scan fields at about 60-foot swath width, so a pretty wide swath. And since it's 24 inches or so off the ground, go as fast as field conditions allow. So you might be familiar with like theirs, for instance, kind of a sled style system. That's when you got to pull through the ground basically. So this is a lot more efficient since it's essentially airborne. So once again, this just kind of characterizes variability. But we need actual samples and actual data to tie to that variability to then create those maps. So we're always pulling cores, typically on a 5 or 10 acre grid for fertility. So it's about at least half as many cores if you're used to about a 2.5 acre grid. But with the use of these sensors, we're able to produce a map at about a 10 by 10 meter resolution, about the size of a wrestling mat. Comparing that to a 2.5 acre grid, though, that's 100x the data points. So we're taking half as many cores, but giving you 100x the data. And taking only half as many cores means we can really pull back the price per acre too. So it's a pretty low cost service to get an incredible amount of data. Once again, all of your macros, micros, and other soil properties, and then compact